Hello, my name is Deborah Emeni, and today I'll be talking about smart contract security vulnerabilities, which is a very critical topic when you want to consider building blockchain applications, something that you should actually, be knowledgeable about, because it's not all about building blockchain applications, it's not all about creating decentralized applications. You have to think and put into consideration security vulnerabilities that a smart contract could have. And also, I'm going to mention in later on in the tutorial some best practices that you can take, that you can put in, that you can do to actually help reduce the vulnerabilities that your smart contracts could have, and that can make it liable to, at cyber attacks and all of that. So moving forward, I'm going to start with an introduction where I briefly talk about the blockchain nature, highlighting a few points, and also the blockchain trilemma. So as you can see on your screen, you have decentralization, scalability, and security. So, blockchain is a distributed and decentralized database that stores transactions in a chain of blocks that do not allow transactions to be changed. So the nature of the blockchain has to do with decentralization, scalability, and security. So the blockchain is public and transparent, but it doesn't really have, privacy. It doesn't necessarily have privacy. I think that's the word. So this brings me briefly to talk about the blockchain trilemma that was termed by Vitalik Buterin, which entails that the three properties of the blockchain that I mentioned earlier and that I have on my screen, from decentralization to scalability and security, are mutually exclusive. So decentralization is the concept of creating applications that do not have a central authority controlling the operations and where decisions are made, and a consensus is basically achieved by nodes on the network before a transaction is approved. While scalability has to do with the robustness of the blockchain system, where it can easily expand to handle more transactions that grow by the second. Then we also have security when it comes to the blockchain being able to defend itself from attacks. So meaning that the blockchain can be decentralized and scalable, but not secure, and vice versa. So that's what the whole blockchain trilemma that Vitalik actually pointed out to us about the three main properties of the blockchain, which is decentralization, scalability, and security, and how they are all mutually exclusive of each other. So depending on the project that you're building, you can't get all these properties together in full. You have to prioritize which property you want in your project based on your project's needs, based on the goals of your project, based on the aims of your project, and all of that, which I'll talk about later. I'll actually talk about those factors that you should actually think about before you can design a blockchain system or design a blockchain application. So moving forward, let me briefly mention some of the use cases, point out some of the use cases, that is the benefits of the blockchain and all of that. So when it comes to the benefits of the blockchain and how lucrative it is, and also how transparent the source code is, hackers see it as a primary objective to attack it. I mean, they know if they are successful, if they have a successful attack, they know how much they can get. So, they see it as a primary objective to attack the blockchain system. So your blockchain application is not safe from hackers. And also it's safe to note that the blockchain applications, a blockchain in general, is not immune to cyber attacks. So it's possible for it has been recorded in severally, in time past, how hackers have hacked and performed cyber attack on blockchain applications that have made those blockchain organizations, those DAOs, to lose a huge amount of money to these hackers. So this is real, and this happens every day in our in our tech ecosystem, in the blockchain ecosystem rather. Right. So some of the major use cases of the blockchain include reliability. By this I mean the decentralized nature of the blockchain. where in case of any crisis, for instance, where a server crashes on the network, on the network, you have several servers that actually that could be on the network, coexisting on the network. In normal application, centralized application, not even a decentralized application, you have several servers on the network. Same with a decentralized application. But in this case, the way blockchain makes the application reliable is when this application will continue to run and be available regardless of any server crash. So if any server of the blockchain actually goes down, since the other nodes on the network, the server nodes, actually the same thing, other nodes, that by nodes I mean the computers are actually connected usually across the network, communicating with each other. So where the other nodes on the network actually have a copy of the operation of that particular blockchain network. So in case any node goes down, other nodes can take up the responsibility and the operation of that blockchain will keep going on. So the application, that's a decentralized application, would always be available to use by the users and and all of that. So that is one very, very important and vital use case of the blockchain reliability. Then we can move on to talk about the trust aspect. So there's the trust, which is another advantage of the blockchain, where smart contracts, which are basically executable code written that specify conditions that two parties must agree on for transactions to be executed. So when these smart contracts are deployed on the blockchain, the transactions created cannot be altered. So that is how trust is being, defined in the blockchain, in the blockchain space for users of the application and also for the blockchain developers themselves. So as you can see on my screen, I pointed out the use of consensus algorithms, proof of stake, proof of work. So those are consensus algorithms. I may not really go in depth. You can actually Google or do your research on these consensus algorithms. But this is how blockchain actually achieves trust. It actually uses the consensus mechanism where you have for like proof of stake, for work, they have like, validators on the blockchain and all of that, but they have like different scheme of how they operate. So moving forward, you have security. Another major use case of blockchain is security. So which is, I know this tutorial is actually on the smart contract, security and vulnerabilities actually in the smart contract security. So security is actually a very key aspect in blockchain. So where in blockchain you have like cryptography being used to encrypt and decrypt transactions that happen in the blockchain. So along with this, the blockchain uses digital signatures as well to prove ownership of assets. So it's very difficult to tamper with transactions that are stored in the blockchain because of how they are stored. So moving forward, let's see some of the risk factors to consider when designing a blockchain app. For that, I want to give like a background, information before I actually talk about these risk factors. So, when designing a blockchain application, there are certain factors you need to consider before choosing the kind of network you want to use. Either private or public network that will suit the goals of your business. So depending on the goals of your business, depending on the goal of that application, that decentralized application, that DeFi application you're actually building, you have to consider the kind of network you want to, build an blockchain on. Will it be private? Will it be public? So this entails putting into consideration on how you manage permissions for the network. So a very good example of a public network that has anonymous computers connected over the internet to achieve consensus by, validating transactions before they are alerted to the blockchain is the Bitcoin network. So, how the Bitcoin network works is it uses or has miners that solve cryptographic puzzles in the process of mining the blockchain to validate transactions. And you also have the private network that is also called permissioned network, where the ones that will validate the transactions are selected. So the users that verify the transactions must be well known in the case of private networks. So when vulnerabilities are spotted by a hacker, the blockchain application isn't as secure as things anymore, right? So it can be prone to cyber attacks and all of that. And like I mentioned earlier, in the past, several decentralized organizations, right, that would have been or have been robbed of a lot of money by hackers. So when it comes to these attacks, there are several of them that you should be aware of that include, we have civil attacks, SYBIL, civil attacks, which is a situation where an attacker or hacker forges or generates random nodes to mimic the nodes existing on the blockchain and floods the network with those nodes with the intention of crashing the blockchain system. And you also have another type of attack, which is, there are several of them. I'm just going to mention like two. So there's also another type of attack, which is called phishing attacks. So PHISHING. So this type of attack is an attack that aims to steal users' credentials, like their login credentials. So basically, the attacker pretends to be the user that it takes on the identity of the user, and there are different types of these attacks. And if the hacker succeeds, this could lead to losses on the blockchain network and for the users themselves. So before I point out and talk about some of the best practices that should be put in before, or should I say risk factors that should be considered before designing a blockchain app, or later on I'm going to be talking about some best practices that you should put in place before writing a smart contract. But for now, let's see some of the risk factors that you should take note of before designing a blockchain application. So let's see the first one, which is the type of data. As you can see on the screen, I have like one which is saying type of data. So first of all, you have to consider the type of data that will store in the blockchain. Look at it, consider the type of data before you actually come up with the kind of design you want to use for your blockchain application. Then secondly, you can have like a recovery plan for the participants of the blockchain in case of a disaster occurrence. So in case of if anything goes wrong, you have like a recovery plan, so you're safe. Then thirdly, when it comes to management of identity, from the management of keys and encryption of block payloads, that may include, using solid management for private keys. And also we have one for model of governance, where you have to consider the model of governance for the members of, participating organizations and all of that. So now let's see the best practices you should look out for when it comes to writing your smart contract. When it comes to smart contract security, one of them is performing regular security audits on the smart contract that may involve testing the smart contracts for vulnerabilities or faults. So testing, what I mean by performing regular security audits on the smart contract, hackers actually go performing cyber attacks on this blockchain application. They could try it on your application to see, and once they do that, what they're actually looking for vulnerabilities in your application, right? So if you on your own, while you have smart contract security in mind, you can on your own perform regular security audits, not just one time, regularly, because these hackers, you don't know when they might come up. So you have to be on the safe side of be on the safe side where you perform regular security audits on smart contracts. An example of performing regular security audits is penetration testing, also known as pen testing. So what penetration testing is? Basically a type of testing that imitates a cyber attack. How a cyber attack should look like, and then you imitate a cyber attack against your own application, and you're doing that with the aim in mind or goal in mind to check for the vulnerabilities that hackers can use to attack your application. So you're actually preparing ahead in case of an attack. So by doing that, once you do that, perform pen testing, for instance, that sort of security audits on your blockchain application regularly, you most definitely see some vulnerability points that you have in your smart contract that if hackers see, they can use that as an edge to perform cyber attacks on your application, and then you can solve those, fix those issues that you have in your smart contract, and then it should prevent and improve the security of your smart contract. Another one is going out of your way, checking out, doing research, checking out leading organizations, leading blockchain organizations, leading DAOs, and the kind of best practices that they put in place for to secure the application. You can actually do research and have conversations with these people and know what they use, and also implement it in your own smart contract. Okay. Also, Another one is, while developing your smart contract, you have to be cautious and careful enough to use only tools that have been accounted for, that have been tested and trusted as well. You can't just use any kind of tool. You can't just use any kind of tool to build a smart contract. You can't just use any kind of tool. You have to use tools that are actually tested and also trusted, tools that are accounted for. All right, while you're developing your smart contract. And lastly, the last one I would like to mention, I know there are a couple of them out there, but last one I would like to mention is scanners. So it's very possible for you to use automated. There are actually several automated scanners that are actually available out there that you can actually use in your application. And one of them that I actually mentioned on my screen, listed out on my screen, is Securify. So Securify is a very good automated scanner that you can actually use to check for vulnerabilities in your, DeFi app, and that's in your visualized application, and check for vulnerabilities and all of that. There are a couple of features, amazing features that actually come with these automated scanners. You can actually do your own job and go and do research, and you'll find out how these scanners, automated scanners, work, and how you can use them to like automate the checking for vulnerabilities for your smart contracts and all of that. Also, you can check the Ethereum documentation to see some of the vulnerabilities that you may encounter while building your own blockchain application with Solidity, how to deal with it. I have a tab open here that's this on ethereum.org. You can go to developers in the docs section, and you can go to smart contract security. So here they actually does give like a brief description of Ethereum smart contracts, and also all this, and then audits and all blah blah, and the development process of smart contract. Then what I'm actually interested in is the attacks and vulnerabilities. So it said, now that you're writing Solidity code using an efficient development process, let's look at some common Solidity vulnerabilities to see what can go wrong. Like they mentioned, reentrancy. So reentrancy is one of the largest and most significant security issue to consider when developing smart contracts. So while the Ethereum virtual machine cannot run multiple contracts at the same time, a contract calling a different account, different contracts, process the calling contract execution and memory state until the call returns, at which point execution proceeds normally. So this pausing and restarting can create a vulnerability known as reentrancy. So here's a simple version of a contract that is vulnerable to reentrancy, as you can see here, contract victim function and all of that. So to allow a user withdraw ETH, blah, blah, and all of that. So you can actually go through this and look at this. And they also mention how to deal with the reentrancy, the wrong way and also the right way. So you can actually take your time and actually go through this, and also look at more attack types, and also security tools as well, and and all of that. So I've come to the end of this tutorial, and I hope you've been able to like learn a couple of things that have to do with smart contract security. Thank you.